Hi, today I'll be presenting our paper, Bootstrapping Chatbot Interfaces to Database. Myself, Ashish, and my team, Deepthi Kalyan Saha, Parag Jain, Jaideep Sen, Manas Ajami, Karthik Sankanayan. This work was done while these folks were at IBM, and this paper has been accepted at COTSCOM 2021. So let's just get started. So this is the brief outline of the talk. So first I'll describe the background of the problem. Then I'll introduce the motivation of bootstrapping. I'll present some high-level algorithm for bootstrapping, some challenges associated with the task, some results, and finally I'll conclude my talk. So let's just see. So first thing that I want to introduce are the chatbots. So chatbots are very ubiquitous, right? Most of us would have interacted with at least few chatbots uh, while we are working in customer care setting and many other settings, right? So in an essence, a chatbot will have three core components. So first component is intents. So these are collection of natural language utterances, which essentially means same things. uh, Next important artifact in a chatbot is entities. So these are the named entities that might be present in databases, knowledge graphs. Basically, these are some of the things that we refer to. And then the thing that combines both intents and entity is dialog states. So this is the heart of or the computational engine of the chatbot, right? So what does a dialog state has? So a typical dialog state will have an input. So when we want to trigger this particular dialog state, right? So is it on matching a certain intent or matching a certain entities or combination of both of them? Uh, then a dialog state will have variables which will be used to maintain the state of the conversion. So which in this case is the person name. Uh, and then there is an output step, right? Which in this case is emitting the OQL query. It can be triggering or calling an API, just printing a string, right? So it can be different kinds of things. So this is what a typical dialog state comprises of. Now, in our paper, we are talking about natural language interfaces or convolutional interfaces to databases, right? So, databases typically are effectively used to store information, knowledge graphs, uh, NRE relations, right? So in our world, we are representing the model, the domain model, which is described in the database using an ontology, which typically has concepts, properties, and the relation between them. So in our small example, we have concepts like drug, treatment, symptoms, and then they can have properties like uh, a drug can have property like name, brand, comments. Similarly, symptom table can have several properties, right? And then there are edges between them. Ontology can also represent many more kinds of relationship like inheritance relationship and union relationship. So it's a much better choice for modeling a particular domain, right? So with the background in our mind, let's just see what we are proposing. So in this paper, we are proposing two uh, uh, methods. So one is offline method, which using the domain modeling that we have just described and the chatbot model that we have just described. First step is to take that domain model and the chatbot model, and then using the domain information, we fill the chatbot model, right? So we prepare intents, we prepare entities, we prepare dialog states, the transition between them, the conditions and everything, right? So that is the offline step. So whenever a user is using our system, so he'll first go through the offline mode, which will bootstrap the domain information onto the chatbot uh, artifacts. And then there is an online phase. So in online phase, a user will ask a query, which will come to a controller, which will send that query to the runtime, where the dialog runtime will figure out the intents, dialog entities, what is the response to be generated. And then controller will pass that to a translator, which will generate a query which can be executed over database. Right? So this is the online loop of the things where things are happening at runtime. Users are asking questions, and then controller will take care of interfacing between the chatbot runtime, the translator, the database, right? So it's the entire interface, right? So our system comprises of two core things, offline and online. Next, I'll describe the offline system, right? So the core component in our offline system is the natural language generation. So in this work, we start with something that we called iGoal, right? So these are, so we show some examples here, and these are some of the queries that we want our chatbot to handle, right? So this is like first query is very abstract query, right? You just want to select a string property from a concept. That's it, right? Now, this goal has no meaning without the domain. So when we are given the domain information in the form of an ontology, we can instantiate this goal to a domain specific goal. So using this iGoal, we can specify that, okay, select a name from patient's table. And then once the D goal is generated, then we generate all the possible natural language queries of that particular OQL queries, right? So, and for that, we use alternate else thesis. This is a rule-based thesis for generating natural language queries. Uh, Similarly, next example is a much more complex OQL goal where we are joining two tables and then there is a condition on one table and the projection on other table. So basically, we want to see what is the dosage for a particular drug, right? So we are joining these two tables. So with respect to the ontology, this I goal is instantiated to this particular goal. And then once we get this particular D goal, we generate the natural language queries, right? So using this, we populate the intents and the dialogue artifacts of the chatbot model. But there are several challenges associated with that. So let's see what are those challenges. So first challenge that we see is ambiguity. So let's just take this as an example. In this one, there are two goals that we have created. Show me drug where for a patient's first name, and show me drug where we are conditioned on patient's last name, right? So what happens if first name and last name contains a common entity? So if the natural language query that we generate is unambiguous, like show me drugs where first name is Anderson, then we are good, right? Because all the information is present. But when we prepare the succinct form of this, like show me drugs for Anderson, then there is a cause for ambiguity, right? Because this can also be present in other intent, which is show me drugs where last name is Anderson, right? So first, so there are many reasons for this ambiguity. One is duplicate names or synonym of the ontology elements, same value or its variation in multiple columns, multiple path between concepts and ontology, multiple aliases, right? So there are many possible reasons for this ambiguity. So our solution is we first identify the examples that are causing ambiguity, and for each such group, we create a new disambiguation intent. If that is caused by an entity, we also create an ambiguous entities, and then we handle them in the dialog state. So what we do in the dialog state is this: we condition on the ambiguous intent. And if we identify, okay, ambiguous query has been asked, then we ask for a clarification question, right? Did you mean first name or last name? And whatever is user's response, based on that, we switch to the dialog state corresponding to the correct intent, right? So using this, we handle disambiguation in the dialogs state transition diagram. Another problem that we often see is non-sentential utterance and co-references. So these are very common in conversations. So what is an example of that? So if my first query show me side effect of aspirin, next query show its dosage. So in this case, its is a co-reference referring to the term aspirin. Similarly, what about desperin? In this case, I am replacing aspirin with desperin, right? So for each of such queries, we generate the partial order in the OQL queries by matching various clauses. And for each such partial order edge, we add intents and dialog states corresponding to co-references and non-sentential reference, right? So for example, for these two queries, we'll be creating a co-reference edge. And once, we'll create an intent for co-reference. And once the co-reference intent is identified, then we make the appropriate transition, right? So this is how we handle NSUs and co-references. Another feature that we found very useful in our system was query suggestion. So this helps user in navigating through the system. So again, we use the algorithm as described in the previous section, that we use partial ordering between various kinds of queries. And let's say if I'm asking a particular query, then I show suggestions which are uh, next in the partial order tree, right? So for example, if my query show me Italian restaurant, then I can say where area is at Edinburgh, where a condition is added to the previous question, right? So using this, we find out various useful query suggestions, and then we show some of them. Next, I'll show our results on two data sets. So first is NLIDB data sets, and second is conventional data set. So in NLIDB, we are checking the effectiveness of the NLQs that we are generating, how well the chatbot engine is able to recognize them at runtime. And in conventional data sets, we are checking for whether the chatbot is able to model the co-references, NSUs, can it handle context and other things that are associated with conversion data sets, right? So uh, for the NLIV data sets, geo and mass, we get state-of-the-art performance. So basically, that tells us that this is this is a reasonable solution to deploy, where using these natural language variations that we generate for each intent, the classifier is able to identify and classify among them, and it works well. For the conventional data set, we perform a user study where we measure the effectiveness, as well as we want to find out qualitatively how well the users find the interface, how easy it is for them to use. And in those experiments, we find that when system is having query suggestions, then people find it much more easier, much more uh, conducive to use the interface. So the idea there is that since users are new to the system, they don't know what type of queries will work, what kind of errors that are present. But when we have suggestions that are present in the interface, then they quickly adapt, right? That what are the wordings, what are the phrasings that will work with the system. So suggestion is a really important feature to have in a conventional interface. So just to conclude, we present an alternate to NLIDB using commercial chatbot engine, and traditional NLIDB systems are black boxes, but since we rely on a chatbot system for all the computational logic, they become open box. And we show experimental studies on both NLIDB and conventional, showing that the system is effective. Next, I'd like to show a small video of the system in practice. So in this work, we are uploading Excel, which will be then converted to database. So this Excel is very simple. It has a person table which with having certain attributes. And then there is a table project. So project table, and then person and projects is an M-to-N relationship. So basically this instantiate WCS button is a one-click button that will generate all the offline process. It will basically create the intents, entities, dialog state, and then it will put in IBM's Watson Assistant workspace. So basically it will create the workspace. Next, I'll show the workspace. So yeah, a new workspace has been created for this particular examples. So now I'm showing some of the intents that are created. As you can see, for the small database, we created roughly 195 intents. Similarly, we create all the entities, all the named entities that are present in the database. So we create entities corresponding to them. Also, we show that since this is a white box, right, a user can come in and add in few examples if we choose to. Similarly, this is the dialog tree. As you can see, right, we have a non-sentential utterance intent created for NSUs and core references, and they link to the appropriate intents, right? So if I ask a particular question, it shows the answer. Show me maximum age, it shows the answer. If my follow-up question is something like per state, it understands this as a non-sentential queries, and it will give the answer group by state, right? So basically it handles and take care of the state transition, right? So this is how we model the entire system, and then we base it on Watson assistant. Uh, thank Thank you for listening. Hope you had something valuable here. Thank you.